Morning, everyone. Good morning, Shloak. Am I audible? Good morning, everyone. Today, on the second day of this faculty development program, our first session is on natural language understanding for market analytics. Today's session will be led by Mr. Shloak Gupta. He's a data scientist at Walmart Global Tech. I'll take this opportunity first to invite my colleague, Ms. Sangeeta Kumari Ma'am, for a quick introduction of our speaker for the session. And you can start. Sangeeta ma'am, can you hear me? I've enabled the mic for you, I guess. That was the problem.
To introduce and welcome our speaker, Mr. Shloak Gupta. Mr. Shloak Gupta is currently working as a data scientist at Walmart Global Tech. He is passionate about solving business problems by extracting insights from the data at scale. He has presented 5 research papers in some well-known international conferences. His research contribution mainly involve applied data science and natural language processing. He has completed his BE from MBM Engineering College, Jodhpur, and MS in data science from Syracuse University, USA. I welcome again Mr. Shloak Gupta.
Thank you for the nice
Thank
introduction.
you. Thank you for the introduction. And Abhishek sir, let me know when I can get started.
Yes, look, you can start.
Yes. Okay, let me share my screen. Can you see the screen?
Yes, it is visible.
Okay, that's great then. Okay, thank you all and a very good morning for everyone. Let me know if there is a lag in between. Sometimes it does happen when we are streaming the video there. And let me quickly introduce myself. Ma'am already did, but let me add a couple of things. So I'm working as a data scientist at Walmart, and I will be talking about natural language processing and AI in marketing. So before this, I did my bachelor's from MBM Engineering College in information technology, and after following that, I did my master's in applied data science from Syracuse University. Had a couple of internship in various domains, mainly one in Nokia Bell Labs, where I worked on natural language processing, and I was working on natural language processing as well throughout my masters in a project illuminating, which we will see in this presentation as well at a later stage. So let me get started. And first, we will cover natural language processing, and then we'll talk about marketing analytics and how people are using in industry right now. And yeah, so okay, so let me give an overview of natural language processing first. So there are various tasks that can involve natural language processing. One is like question and answering, other is like giving sentiment analysis, topic modeling. So basically all of these algorithms follow a particular pattern. You first have the training data sets, you extract features. As we know that computers or algorithms do not understand words, so there has to be a way to extract features out of the text. Once we extract the features, convert them to numbers which are understandable by these algorithms, then we go ahead and train a predictive model corresponding to the data and the label. Once the model is trained, we go and put that in the real world scenario and see how it is performing. So there has been a lot of developments in the recent past, particularly in the natural language processing. It has been the domain of interest for various scientists and researchers across. There has been a lot achieved in visual scenarios, for example, image processing, video processing, giving videos and subtitle. But natural language processing is still a very developing domain, and there is a lot of research happening. Every couple of months, you will see researchers across the world coming up with new algorithms and taking that to a next place, making it easier for a young data scientist or a AI researcher to use these algorithms, duplicate the results that they are having, and use these then to in their particular domain where they wish to apply these algorithms. So mainly I will be talking about an algorithm that Google developed almost a year back, which is like BERT, and we'll see how it changed the scenario and what new it has developed in the natural language processing domain and where it can be applicable in various scenarios. So, firstly, I will give you a brief introduction about neural networks. So, neural networks basically each neuron act as a linear regression unit with non-linearity introduced. So, you can consider each neuron in a deep learning network as a single linear regression unit. Over top of that neuron, we applied the non-linearities. So, we can get the non-linear relations in the data as well. The more the layers, the more complex relationships a neural network can get. As we know that with natural language processing, there are a lot of complex relationships that are there in the text. For example, the words can be related. A word can be related to another word, which is like six words ahead of it or four words behind it. So it is very important to get these relationships. A neural network lately has been effective to understand these relationships, and then when it comes to predicting, use those relationships to predict the task that we assign it to do. But as these networks grow, it becomes tougher for first of all like to get that amount of data and also the computing power to train these models. So these are the drawbacks that I talked about. First, it is like costly to get that much amount of processing power or GPUs. Plus, it is also very time consuming to get these models trained and then test them out in real world scenarios. For example, one of the models that has been recently trained for natural language processing, GPT, almost takes $80,000 to train once on a Google cloud platform. So as we can see, not everyone can afford $80,000 to train these models, or as well as like afford to spend like 6 days to train these models and then test out, and if it's not performing, spend like another 80,000 on training these big huge models which have been performing good. So Google came up with various ideas and compiled them all together in this model which is now known as BERT. It is a the full form for BERT would be bidirectional encoder representations from transformers. We'll go more in depth how it is working and what new ideas it introduced. As you can see that this paper was introduced in like mid 19 and it has taken this field apart. Like a lot of now research is based on top of this model. So this model is acting as a base for the new research that is happening in the world of NLP. Some of the facts with this model, as I told, like it has been really popular. It has already achieved more than 8,000 citations. It was developed by Google Brain, achieved state of art performance in various tasks, almost like nine of the natural language processing tasks. Previously, it was never seen. Generally, models were built to perform good in one of these tasks, for example, question and answering tasks or understanding the natural language. But this model, being a solid foundation to all the tasks that can be performed on top of it, achieved almost state of the art performance in 11 of these tasks. Transformer based models come with like two different parts. One is the encoder part and the decoder part. Other good thing about this model is it is completely open sourced by Google and it can be easily implemented through libraries such as TensorFlow and PyTorch, which are very easily available and very easy to learn as well. So let's see how it works. One of the new and cool thing about this BERT model is how it performs the pre-training of the model. So what generally happens in natural language processing or machine learning is you have the data and then you have to create a labels. For example, if we are looking at reviews on a platform for a restaurant or something, a person has to sit and label that reviews as, like, for example, good or bad, or give it ratings from 1 to 5 to see, and create that data and then give it to a model so model can train and learn from that. But that labeling is a very time consuming process. It requires a lot of human resource and also expertise of the domain. Plus, for example, you did that for a restaurant. Now you are want to do a question and answering task. You have to create a separate data set, separate human resources and cost are involved in that. What it did is, like, it created a way to pre-train these models in a way where no human effort is involved in creating that labeled training data set. So what it did is, like, it took paragraphs from English textbook and Wikipedia articles and masked 15% of the words at random. So I would take, for example, if you look at the input, there is this sentence which is like, the man went to the store, he bought a gallon of milk. It randomly picked out two words and blanked them out and forced this model to learn these words. So now store and gallon would act as the label data in this model, and other sentences which is like, the man went to the and he bought a of milk, those would act as the features given to the model. So now model is actually learning the embeddings and how words relate to each other. Once learned this embedding, these embeddings can be used as a pre-trained model for any other task that involves natural language processing, because the computer or the algorithm has already understood the basic embeddings that are there in the text or a particular language. Another task that it did was to predict if the next sentence was the following sentence or not. For example, the man went to the store, he bought a gallon of milk. So these are two sentences and they marked them as sentence A and B, and the label would be is the next sentence. So when they were picking the paragraphs, they randomly sometimes pick the next sentence as the following sentence and sometimes flip those, or attached a random sentence to the end of the first sentence and then added the label not next sentence. So this is how, without much human effort, we are able to create a label data which can be then used to train these big transformer based models. So this is an example of a learned embeddings. For example, given a political Twitter dataset, it can easily analyze, like, which words come together in the feature domain space and which words are very apart from each other. For example, if we see, like, racism, democracy, these words are talked often enough when we are talking about politics in America, but other words might not be, and they are represented in a different word cloud. Sorry. So this is the fine tuning step. Once we have pre-trained this model using this a unique way of labeling the data and training through the embeddings, on the final layer of the model is a layer which can be customized very easily. You can attach a question and answering system, a topic modeling system, or as well as text prediction system on top of the layer. So this would be the final layer which would be attached on top of this already trained encoder and decoder. These trained encoder and decoders are available, so you do not need to train these models from the scratch again. You can get a pre-trained model from a Git repository that Google has and attach your customized layer on top of it and ask this model to get trained on very less data to perform the task that you want to do. For example, when I did is, like, I did a text classification task. I just changed the last layer, gave a 5,000 row exam set data set to it, and used a model which would never have been possible to be trained. For example, data which is as less as like 5,000 rows and perform optimally on that task. Any questions so far? Okay, I would say that as so what all things that it has changed. So for one is like the dependency on the large data sets. uh, the unique way of labeling the data has changed the dependency on human resource and the domain expertise to create that amount of data sets to train these large models. Other is availability of the pre-trained model in a very on a very general data set. General data set in the sense as it is trained on English textbooks and LinkedIn, so it is not trained on, for example, biological papers or political data or data from Facebook or Twitter, which is sometimes very different from the normal English that we speak or a conversational English. So this model is trained on a very general English data set. So this can be then customized on very specific tasks. People have used it to find similarity between research papers. People have used it to categorize political content, or people have used it to find sentiment analysis, and we'll see how other people are using it in different ways just by customizing the last layer. Another thing that has changed is previously, if we look at the models like LSTM or bi-LSTM or even autoencoders, these used to train from right to left or left to right. So if there is a word that is like, for the example, fourth word in the sentence, it would only know the first three words that came before it to get the context for the first word. But now with BERT, what has changed is when we mask a word, we just mask that word and keep all the words before it and after it as it is. So it is getting context both from the left and as well as the right. So these were the three main things that this paper brought in the scenario, and this helped to uplift the performance of almost every natural language processing task by a lot. People are researching how to even optimize BERT on it. For example, when it comes to the encoder layers, people are now using, instead of encoders and decoders, Fourier transformation for the first few layers, which would increase the speed of this model in predicting for it by 16 times, whereas compromising on the accuracy by a couple of percentages. So it depends on your scenario and application how you want to optimize this model. There are basically two variations of this model available. One is the BERT base model, and then there is a BERT large model. It depends either you want to go for the optimum speed or the optimum accuracy for the task that you have at hand. So some of the tasks that it can perform is like, for example, text classification, question and answering, name entity recognition, automatic summarization, semantic similarity analysis, next sentence prediction, word sense disambiguation, and many more. So having a solid base through BERT enables you to get great performance on all of these tasks, and this is what which is new in the domain of natural language processing, is to create this generalized model which just learn the embeddings between the words and the embeddings of the words, and then help using those embeddings, which would help you to create more complex tasks very easily, just like you do normal classification, or when we use normal algorithms like, for example, support vector machine or a logistic regression. This is the model that I used in Project Illuminating. So Project Illuminating was about analyzing the social media domain for US elections. So we would analyze what each candidate, a Democratic or a Republican or a Trump or a Biden, is speaking about, how much their money they are spending in each of these domains. For example, either they are talking about immigration or social activities or education or racism in US, and how much money they are spending. So what we gave this model as input is the tweets and the Facebook posts that each of these candidates wrote, and then fine-tuned the BERT model on a sample of 5,000 to 10,000 of these tweets to do a classification task, and then created multi-class binary models on top of that to get each category and see how, if the tweet or the post is about that particular topic or not. I published two papers on this. The first one was published at like IC2S2 at MIT on July 17th, where where I talked about how the whole pipeline from end-to-end pipeline from getting the data from Twitter and Facebook APIs, feeding them into the pre-trained BERT model, uh, and then fine-tuning the BERT model, and then putting it to a classification task, and how much it improved. Even though the political words and some of the jargons are very dissimilar from the Wikipedia articles or the English textbooks content that this model is trained on, despite that, we've got a really good performance through that model. As you can see, like I have put a comparison of support vector machine LSTM and BERT for that particular data score, and you can see like almost 9% of gain in the F1 score is achieved when we use BERT instead of the models like support vector machine, which is not like a deep learning model. It just create these features and use it as a normal features, and then train a classification model on top of that. LSTM is more complex, a deep learning model, but the complication with LSTM is it requires a lot of data. We were limited in the number of resources we had and the experts, so we could only create a sample of 5,000 data samples, like 5,000 tweets and the categories corresponding to those. So we could not get very high performance from LSTM. And in some cases, when the data is not sufficient, deep learning models may perform worse than the normal machine learning models as well. And that's what we faced in our case as well. So to overcome this shortage of the sample size, and as well as to get better performance than the traditional deep learning models, we went for BERT and used that and achieved great performance. 90, it is like 83% F1 score, but when it came to accuracy, we were almost touching 97 to 98% because the data set was a bit skewed in our case. We went for BERT based model because we wanted to have this pipeline in real time. But if we want to have larger focus on accuracy and F1 score, we can even go for a BERT large model, which has like 16 layers instead of the 12 layers which the BERT base model has. Any questions like so far about the project or the model? Okay, so let's look at some of the applications that can be used. So there's this example of Instapot. The the owner of Instacart just went to Amazon each day and just read the reviews of all the customers. He looked at the sentiment of the review and then looked at the which which topic it is talking about. So, if for example, if it is about the charging speed or the heating of the pot and the review is negative, he would just go and talk to his engineers and correct that. Through that, he was able to like make his product better and sell loads and loads of it. I can guarantee that in every household now you have an Instapot which is there. So how we can automate this process is, one is like there are two tasks that we can do. First is like sentiment analysis, which is like getting to know the review if it's good or bad. That we can do through BERT. It's like a text classification model. And then the other task we can do is finding out if it's a good or a bad review, what it is talking about. Is it like the charging? Is it about the other features of that Instapot product or anything else? And that we can do through name entity recognition. It will give us like what is the topic that they are talking about in this. So I think there is a question which is what is layers? So layers is like deep learning models are compressed of different layers when it comes. So the input goes to the first layer and the output from the second layer added with non-linearity goes to the second layer, and you can have multiple layers in a deep learning model, and from the final layer the output goes to a function which will give the prediction that you require. Does that answer the question? Okay. Going to the next part is something that I worked on during my internship, which is like given a context, for example, given this paragraph or a passage, you can ask automated questions out of it, and the model would be able to answer those questions. This is very similar to a squad data set that has was constructed by the Stanford University, and it has been used to analyze how good your machine learning model when it comes to automated question and answering. So given this context or the passages that we used to get in schools and then teachers used to ask some particular questions, you can do the same thing with this model. Is like given this passage, you can ask the model like which NFL team won the Super Bowl of 50, and it will give you the exact answer of Denver Broncos. What does AFC stand for? It will give you the answer of American Football Conference. So this model has taken the automated question and answering to the next level, where it can understand the context from the whole passage, can give you the start and the end of the answers in it, and through that you can retrieve the answer from that passage. But where it lacks is like the answer has to be in the passage. You cannot expect it to write summaries for you, or you cannot expect it to have an answer which is like at various places from the passage. It has to be at one place in the passage, and it has to be continuous from the start to the end. You cannot ask it to summarize, for example, like what are the items in my McDonald's bill that costed me more than $10. You cannot ask questions like this, but you can ask like what is the total uh, of the bill, or what was the most expensive item in my bill. These questions would be able to be answered by question and answering system that can be created easily through the BERT model. A lot of companies are now mixing these kind of question and answering system with the chatbots that they have, or with their call centers, to get the answers of, like, for example, the most frequently asked questions, or just the context based questions that the customers ask to them, and it has seen to be very effective and decrease their load by a lot. This is the area where a lot of companies are investing a lot of money, because it decreases the dependence on the human resource quite a bit for them. Other thing that is happening is how we are interacting with machines is also changing, with automated question and answering systems coming, or we are getting more habitual to chatting with each other. The conversations and the interaction with the search engines is also becoming very conversational. Initially people used to put couple of keywords and used to find the related pages of the websites that they wanted to visit, but now the the question and answering or conversational mode of conversational or conversation creeping on to us, we are asking the search engines also like the queries which are very much in forms of questions. So Google is changing its search engine as well. So now the content on website which answers the questions that a customer put are being rated more, or are being prioritized more in the researchers. So it can bring this change where people have to bring the content which is more conversational on their websites, rather than which is more specific to the keywords, as it was in like the last decade. So with the changing pattern in the search engine queries, you have to change the content on the website as well, and you can find like which content is more relatable to the queries that are coming to your website through the closeness of the embeddings that bot model will give out from the question, as well as the answer and the content that is available on the website. Another thing is like building a recommendation system or giving replacement products through a page or a platform that you are creating where you want to sell these products. For example, I want to launch a, in this case, a new lipstick. I already have a lipstick. If a customer is searching for a new product, I can put all these descriptions through my model and see how close or far these embeddings are. A lipstick might be much closer to another lipstick than an eyeliner, and I know when a customer is searching for a lipstick, I would recommend, if I'm out of this product, I would recommend him a similar product whose embedding is much closer to the product that I have rather than embedding which is farther than the embedding that I have. So without using other descriptions, just from the text, I can see which products are closer to each other or which products are far from each other. And this is being used by a lot of recommendation systems at all the retail websites and the other like hotel booking websites or like the third party engines nowadays. They are using these embeddings so they don't have to depend on a lot of data which had to be calculated or managed by the humans that work in their workshops or the warehouses. Yeah, so that ends the natural language processing part for this presentation. Any questions so far? Okay, let me move on to the marketing analytics part. In this, I will be covering the breadth of the marketing analytics and how it is being used in the industry more rather than the latest research that is going on, because marketing analytics is something which is more used in the industry rather than the education or the research medium in the universities. So let me go through the applications then. There are some of the use cases of the list that I will be going through. One of them would be like targeting the right audience, how companies segment their customers, getting a lifetime value for a customer. We'll first get to know what are these things and how people are doing these stuff and what impact it might create for a particular company. So let's take one use case. So first is like customer identification. Most marketing efforts fail when they are trying to appeal to everyone. You cannot launch a product and, for example, launch to the whole country and see like where you can get the customers. Launching has to be in phases. First, you might start from some of the smaller cities, then go to metros, then cover states, and then go on to apply a product for the whole country. You have to narrow your focus. Some products can be meant only for children. Some products can be meant for people who have already retired, or in particular demographics as well. So, what are important? Sorry, I'm getting a noise. Can everyone like mute their mic? Yeah. Okay. So, what is important when it comes to finding the right audience? Uh, uh, yes. So, some of the examples that can be where targeting the identification, like identifying the right audience is important, is like, for example, if you want to sell the business class airline tickets, or for your example, you want to do online medicine delivery app or a education loan company that you want to set up. All these has very different customers that you want to target. And I have a question, like what are the some of the things that you would focus on, for example, when you are going for a business class airline ticket? What are the characteristics do you think your audience will have? Anyone like want to answer that?
Think hotel also they are looking for.
Sorry, can you say that again? Yeah. So basically, financially good, famous personalities, or people who can afford business class. You do not want to sell a business class ticket to people who cannot afford, or for example, college going students cannot afford business class. So you have to be very focused on a particular demographic and also the income of the people. So So, what are the characteristics of the audience that can be important? One is like gender can be important. For example, if I'm selling a lot of makeup, I would not I would not attract that much of a male audience than a female audience. Age is important. Location, profession, income, education level, marital status, the number of kids someone has can be important for a different kind of product. So these are the characteristics of the audience that each company is looking for, and then they would target their customer to this particular audience. Then the next question is like, this data is important for customer identification or identifying features for my customer, where I can get this data from. There are various sources, both private and public, which are available to get this data. Some data is available broadly at, like for example, a state level. Some data can be at the zip level, and then there are other kinds of data that are available, for example, at a household level, or particularly identifying a particular custom. For example, if they want to find out what are the characteristics of a person called like Shloak, it can be like he is age 26, he's a male, his income is for example XYZ, and then what is his education level, number of kids. So data can be at different level. There are various organizations that collect this data. Some make it public, some sell it for a particular price. There is census data. For example, Indian government right now is doing its decade every decade census, so it gives us the idea of the age age population, or like the also the marital status of people, religions of the people. So that can be also used as these features for identifying the customer base. Then there are private data collectors here. Epsilon and Profile America are really popular. They give you data like almost 1,000 features for each person: how many cars they have, how much they shop online, how many credit cards they have, do they like to go out, do they buy airline tickets, do they travel business, how many days they go for vacation. All this data is available at a particular household level. This data is, when it comes to the application or the impact it might have to your business, that the cost of data is very nominal, and these companies charge you that, and they give you access to the data for the audience or a state that you are demanding. Then there is credit card data as well. How much each person is spending through credit cards or debit card, and that gives you an idea of how much he or she might be earning as well. Other kind of data sets which have become really popular these days is the social media data sets. There is a big concern about privacy as well, but a lot of these social media websites, if your account is public, can give you that data set about that particular person, what they are talking about, how active they are on social media. Because if someone wants to open a medicine delivery app, he wants to know if a person is active on social media or not. That gives an indication if the person is used to mobiles or apps or online shopping as well. So you can use social media data sets as well to create this database. Now, one of the challenges is like some of these data sets are very large. For example, thousands of variables. There has to be a way to select a limited number of variables for your particular problem. How to get to those number of variables that would be sufficient for your model, or how to remove the useless variables once you create this data set. So there are several processes that you can do. When it comes to when the variables grows from like 100 to 1,000, it becomes very hard to look at every variable and judge it, whether it would be useful for your algorithm or not. So some of the ways that I have used in the past is like removing variables with zero or near zero variance, because if it does not have any variance, it will hold no information to the y variable or the dependent variable that you will have in the data set. Other criteria for removing these dependent variables, independent variables, is like the high missing values. If there is a lot of missing information, it is almost as good as no information available from that feature. But sometimes missing information can lead to different meanings as well. Missing information on certain dates might mean that it's a holiday. Sometimes like a feature might just have male. For example, if it's a gender feature, it might have male and the rest are all missing. So that might indicate that the other is, like, for example, female in that case. So you have to be careful while removing the missing values. Then other criteria for removing is like highly correlated variable. Sometimes, for example, if you're going through a flight, the time and the distance can be highly correlated and might give you the same information in this case. So you would remove those highly correlated variables, because in some of these algorithms, correlated variables, when it comes to interpretation, might give you results that are not very indicative of their impact on the y variable. Weak correlation is also a factor when it comes to weak correlation between dependent and independent variable. If the dependent and independent variables have a very weak correlation, sometimes it might indicate almost no information gained from the independent variables on the dependent variable. But these are like the correlation between variables are very specific to the algorithms that we are using. It might impact heavily when we are using the regression algorithm, but might have almost no impact when we are going for example, a tree based algorithm like decision tree or a random forest or a XGBoost. Other way is to cluster the variables through hierarchical clustering, where you would select a bunch of variables which indicate a very similar thing. So when you go for hierarchical clustering, you can actually cluster the variables and select one out of that cluster, which would indicate the information that all of them together would eventually give as well. So that would give you, like, for example, 16 clusters out of 1,000 variables, and you can pick just 16 variables out of it, and that would lead to the almost similar amount of information that 1,000 variables will give you. So these are some of the ways which we can go for feature selection. Then there are methods where we go for feature reduction as well. For example, someone can use principal component analysis, but using feature reduction methods such as principal component analysis has some cons as well. Like, you lose the original variables, and in marketing, no manager would want to have a variable which is not intuitive and does not give you a clear picture. You cannot ask like 0.5x and 0.5y is impacting my business that much, because that is not very intuitive for those managers. They want to be very specific. Like, for example, the customer that I have or want to target are aged between 55 to 60. So when you give this picture to your CEO or the manager, they are more happy rather than having a gibberish amount of a variable which is very good for your accuracy but leads to no information for them, and they cannot trust these variables, so they won't go ahead with these models. So there are some limitations when it comes to data science or AI in marketing. Like, you cannot generally go for deep learning models because they are a black box. What is happening inside and which variables are going through and creating that impact is sometimes hidden, and managers and the people in the industry prefer to have very clear visibility in what they are going and what basis they are targeting some particular customers. Then there are some feature engineering steps involved when we go for these algorithms in marketing or in any domain in machine learning. There are transformations from continuous variables like power, root, log to make them like linearly correlated with the dependent variables. Then there is binning as well. For example, age is a continuous variable. From age can be from like 0 to 100, I would say. But sometimes people, for example, if we are binning all the retired people together, we can just create one bin for 60 to 100 years and have people say labeled as that bin as like retired, or we can have teens from 13 to 19 and create these different bins which we think might be useful to our business. Then there are categorical variables as well. For example, income can be low, medium, high. Models do not understand low, medium, high, so we have to create them in features. We cannot convert these. So this is an ordinal example. in machine learning, so we can go ahead and do 1 2 3 because there's linear. But for example, there are states like Rajasthan, Punjab or Haryana. They do not come in a particular order, so we have to go for one hot coding where we have to create these three variables that would indicate, for example, Rajasthan, and create a binary variable which would say 0 and 1 for Rajasthan, similarly 0 and 1 for Punjab, and a different state. So that would be one hot coding. And then creating the one hot coding and the continuous variable, we can also go for creating interaction variables which would tell you the interaction between a particular state or a income level or a age as well. So I'm giving you a process for like how people go for in-mail customer targeting. So you might be getting a lot of pamphlets, for example, from Domino's, getting like 50% off in your mailboxes or delivered under your door. Each of that mail is done when Domino's identify you as a potential customer. So each person getting that, not every person is getting that discount, but the person getting Domino's think that you fall in their customer domain, mm, customer domain, or you are a potential customer for them. So does they identify that you are a potential customer for them? So first they look at their current customers or the customers of their competitors, and then using the data sets that are available already to them, they give them features. So that would be your y variable and created as one. And then they will add potential customers who did not buy with them, or just random population from the market, and add them to the data set. That would create the zero for the binary model that they want to build. Once they train this binary model and are able to identify that current customers from this random chunk of people where they have a mix of customers and non-customers, the model is trained. They have identified the features. Now they can use this model to mark a completely random audience and then see how each person is getting scored. So they set a threshold, for example, 0.7%, and if a logistic regression model or a random forest model or a decision tree gives you a threshold about that, gives you a score above that threshold, you are a potential customer for them. They will send you these offers, pamphlets, uh, to you, and wait for a particular amount of time to see if you buy with them or if you place an order using that discount coupon. And then if they do, then you can be, then that marketing campaign is just as like successful. So this is like just going over it again. So first, looking at your current customers, appending demographic data to your current customers, and then a set of random people which are not your customers. That would give you the training data set. Then when you go for model training, is like feature selection, engineering, selecting a model which is performing good for you. Uh, Dependent variable would be a new person, and then using that model to mark that new person and see if they pass a particular threshold or not. uh, when judging marketing campaigns, you have to decide the criteria to judge your marketing campaigns or these algorithms. There can be various ways to judge that. One can be like the response, like how many people place that order, or how many percentage of people that you mailed place that order. The other can be the revenue that got generated from that marketing campaign. You spend it like a lakh rupees in that marketing campaign. How much revenue generate did you generate? Like 5 lakh rupees, or like did you generate 50,000 of your of the revenue? Uh, Additional things can be added on to these scenarios as well. One can be A/B testing. So if you're giving an offer of like a pizza free with a pizza, or you're giving a 50% off on a pizza, so you can send half of these templates to to a certain group of people, and half of these pamphlets to another set of people, and then analyze which campaign did better among a big campaign. Like, did the 50% offer did good, or did buy one get one did good? So that would be like adding on to things on a customer identification model, or a campaign. any questions? So I see there is a question about the logistic regression and ensemble methods. I would say I can send a link at the end of presentation because I think I'm talking more towards a business perspective, and going into these algorithms in detail is like would be going off the topic a bit. So yeah. Okay, so embeddings is basically embeddings is the embeddings in this case would be the output of the last layer of a deep learning model. So when we go for images or text, before the last layer, which is a function, for example, a softmax function in classification, you keep that there. For example, there are 254 neurons in the last layer of a deep learning model. You just keep that output of those 254 neurons as an output for a particular text or an image that you gave to that deep learning model. So that 254 neuron output would act as 254 features uh, for that particular text or image, and those 254 features is then called as an embedding for you. Now you can go for example, something which is like PCA, which would reduce that 254 dimensions in like 3 or 2 dimensions, and then you can analyze how close those two features are to each other when you go ahead and plot them in, for example, a 2D graph and a 3D graph to see what's the distance between them. Or if you do not want to go for visualizing, just marking them, you can use something as like a clustering or a BB unsupervised grouping algorithm to see how close to embeddings are each other, or even calculate a Manhattan or a Euclidean distance between those embeddings. Does that answer the question? Uh, s- I didn't get that question that much. Is it like are like financial products which are similar to each other suggested to a similar audience?
Yeah, can you hear me?
Yeah, yeah, I can.
Hi. My question was specifically in the area of finance for high valued customers who have got more than like 1 crore or so. So for them, a lot of these financial products have been recommended using lot of AI models.
Yep.
So they have gone for association rules is what they looked at initially, and then they started using a lot of prediction models also. So has there been any lot of research or any specific models which have been used in this area?
I would say like models is when it comes to marketing and recommendation, the models has been very like basic. There has not been a lot of development in terms of models, but there has been a lot of development in how they get the data to go into these models. Because when it comes to machine learning and AI, the data is as good as, or I would say more important than some of these models. There is one new thing that I'm going to talk about in like going forward is like a lot of companies are now going for customer lifetime valuation. For example, I have joined this new bank or a new platform, for example, Netflix. They will judge how good a customer I will be in going ahead in 10 years, how much revenue I'm going to generate for them. And then getting these different customer segmentation for higher valued customers and low valued customers. They would like market different things to different people in these things. And when it comes to like for example, when you are saying like they identify these high value customers and sell some products to them, it is like a very similar example to identifying people who would travel business class. So keeping the features same and then identifying the current customers, finding similar customers to their current customers, and then going ahead and marketing to them. I would not say that there has been change in the algorithms that they are using, but they are certainly shifting from association rules to predictive models because of the ease of the data that is available right now.
Shall I ask another question?
Yeah, sure, go ahead.
Yeah, so the question to add to the question, specifically when it comes to these financial products, they keep on changing, right? So that means the valuation keeps on changing from 1 week to another week. That means the recommender systems which are there should be able to take that historical data, make those suggestions, pertinently changing it over a week. So then what happens is if we suggest any product to them, they might be very happy in the previous week, but things have changed in the stock market and suddenly we see that that product is not doing well. So in that case, what would you recommend?
Yeah, I'm not that savvy with like the financial market as per, and I have almost like zero experience, particularly dealing with financial products. So yeah, I would not like. I would say I'm not the best person to answer that question for particularly financial products. Yeah.
Thank you very much. Thank you.
Okay. Any other questions? So we have. Yeah. Yeah, there's this one question that is like, is it possible to get 100% correct prediction using AI? If not, why? I would say like it's a very hypothetical question, but I have never seen something which is like 100% accurate right now in AI as well. And if it is, there might be like overfitting because there's nothing which is like perfect. And sometimes when there can be noise in both the prediction as well as data collection, which might lead to some of the errors that we might get. And if your model is there are a lot of factors in the environment, and if not why we can get 100% accuracy is like there is only a certain amount of data that can be calculated for certain things. You cannot calculate like everything that is available, so you cannot predict everything to up like 100% accuracy. But let's move on to the next topic, I would say. Next is like customer segmentation. So once we have identified the customers, there is another thing that we need to do is like segment our current customer base. Is like customer segmentation is the action of like breaking down your company base into groups of dependent people. For example, if there is an airline company, it want to break down its customers in like business class, normal class, frequent travelers, business travelers, non-frequent travelers, so they can market them specifically or cater certain features of their product for that particular segment. So it's like reaching out with the right message about your products to the right customers, and that's what it takes. For example, now let's take the business case of Hilton hotels. What can be different segments? Let's look at them. There can be like business travelers, which are like frequent travelers. They travel a lot. People working in consulting companies or people going to conferences from one place to other. Or managers of big company which manage multiple offices, going from Bangalore to Chennai to Delhi to interact with different teams. There can be vacation travelers or family travelers which travel in a bunch, like going with a whole family of 7 to 8, booking 3 to 4 rooms at a time when they go. Then there can be retired people just chilling out, like spending their life like partying, or like going to calm resorts around the world and spending time there. Then there can be youngsters, single, low income people like below 35 who have started going to these hotels instead of like cheaper options like Airbnb or hostels. So that can be another audience. And how you are catering or marketing your company, or like in this case of a Hilton holder or a Marriott properties, can be different for each of this segment. What you are offering to retired people is very different. So what would attract a youngster who has just started traveling or who has just started earning new money? Similarly, for business travelers, they would want ease of booking or like some loyalty program, which would keep them to this brand. And they would prefer locations which are like closer to airports or closer to the industries that they would be traveling, rather than some vacation locations in like Kashmir or Goa. So the data that you calculate is get for customer segmentation is very similar to the data that you do for customer identification. It involves like demographic spend habits. Some of the new things that you get for customer segmentation is they already are your customers. So you would have data like user engagement, how frequently they are engaging with the your product, how much revenue they are giving to you, and also how much they are involved when you launch a new product. Are they willing to test it out? For example, youngsters might be, or retired people might not that much be interested in the new things that are coming to your product or a new offering that you are willing to make. So the process for customer segmentation is the current customer database of engagement, spend, demographics, and other features that might be very specific to a business. We don't have a label data, so when we have, for example, 100 customers, we do not have particular customer segments already in our mind. If we have in our mind, then it becomes a supervised machine learning problem where you go and mark those data sets. But if you don't have particular customer segments in your mind and you just want to see if there are certain segments of people that, or segments of customers that are in the data set which are very similar to each other and are dissimilar to some other segment, then you can go for something which is like unsupervised learning. You can use algorithms like k-means clustering or db-scan, and these algorithms will give you like the number of clusters you have in your data set. It might point you like two of four clusters or five clusters in your data set, and then you can go ahead and in an artificial way turn it into a supervised learning algorithm where you would mark these clusters 1, 2, 3, 4, train a model, and then perform some feature importance technique to see which features are important to each of these clusters. For example, for retired people, age and income might come out. For youngsters, also the age and income come out, but in a very different way. So these would algorithms will give you the clusters, and then you can on top of these clusters put a supervised learning to get the feature importance and see which features create the maximum distance between these clusters, and then start identifying those groups that are in their customer base. So going to the next topic, and this is very new in the industry. People have started realizing its potential very recently because a lot of budgeting has started happening a lot earlier in major companies rather than like once they have the budget, because a lot of things are now running on credit rather than having that money and then spending it. It's more about predicting the flow of the money that you will have in coming 2 years, 3 years, to attract more investors, and also putting that investment early in people and resources, and then getting like 3 times or 5 times bigger profits in future by spending that money on credit earlier. So you have to in a way predict the income that you will have in future from the current customer base or the people that you are having, so you can easily spend and confidently spend that money in future. So it is about how much a customer will be spending on a platform for a lifetime. If I have joined a platform like Coursera, how much Shloak Gupta is going to spend on Coursera in his lifetime. Some companies treat lifetime as your lifetime, some companies treat lifetime as, like, for example, 5 years or 10 years, depending on how new the platform is and how much further they want to go into future to calculate these revenues. Uh, there can be multiple users in this. For example, there can be like differentiating between a good customer and a bad customer. For a company, a good customer is who gives them more revenue, and a bad customer is who gives them less revenue. uh, Other thing is to predict the future income and allocate that money on marketing, research, or getting new hiring new people, or getting new offices that they might be planning to do, and want to confidently spend that money because they know that they will be getting this much money from their current customers anyways. Then defining marketing around migrating those customers. When I say migrating these customers, is turning good customers into bad customers. And how do you do that? Is like identifying some of the features that differentiate the good customer and a bad customer, and then working on those things to change them around. So that's the business case that I talked about. Is like Coursera. How much? What are the important factors to judge a customer's lifetime value? How much like they make on each course? Right now, they are charging, for example, $50 for a month, for like one course. So that would be one thing. Judging that each customer will have one course, so they will get $50. Now, depending on how many average courses that a customer takes, like is it like two, three, one, or like even close that one out, or like consider that, like, or taking like some, if they sign up with a college or a school, they might get even like 25 courses with different students but on the same account. Then there is a important thing which comes in it, is like, so how much they make on a course, and how many number of courses a person takes can be very standard. Like they can charge $50 for a course, and a person can take one course per month. But then what differentiates a good customer and a bad customer is the churn rate or the retention rate. Churn rate is like how many customers they lose every month, and what's the potential of this customer of staying them for another month, or like 3 months ahead, or like 1 year ahead. That would define the churn rate for the company and for the customer as well. So how to calculate the lifetime value is basically average order value, how frequently you purchase that item, and what's the average lifetime of a customer. Other important factors can be like the cost of product and the margin, retention rate, number of transactions, and these are the same things that we just talked about. Then you can see on the graph, you can divide your customer base into three. Is like non-profitable customers, which do not give you, are like what we can call as like as freeloaders. It just come to your website, watch the free stuff, and then just go away. So that would be a customer that will never give you a revenue, or you expect very less revenue from them. Then there can be active profitable customers, uh, which would give you a medium or a mean amount of revenue. And then there can be very profitable customers, which would no happen what if even if product is going through a bad phase, will give you a definite amount of money and are very loyal to you. So you have to balance out your marketing in these three different current customers as well. If someone is very profitable already, you do not want to give them offers, because anyways they are going to stay with you. If someone is non-profitable, you think you are not going to earn anything on them, it does not make sense to spend that much amount of money on them. So you would focus rather on the active profitable customers, which are giving you a mean or median revenue, and then trying to turn them to a loyal customer, which would stay very long for you and would give you a higher potential revenue. So this is how you can predict. So when it comes to predicting the churn rate, you can go ahead and predict if this customer is going to stay with you for the next month and or not, and then use a probabilistic binary model to give it a score out of like 0 to 100 to see like what's the chance of them staying. And then For example, if we take a customer X in this case, customer X has a retention rate of 93%. The amount would we take is same for all the months, is like $50. So the potential amount that I'm getting from this X customer for the month is like $46. Then the second month his chance of staying is like 88%. So there is a 6% chance that after 1 month he will leave the platform. So the value that I'm adding for that customer goes less by 6%, and I'm expecting a $44 revenue from that customer. And when I do it over a year, I would say I'm getting $360 for a particular customer over the year. Now I'm this might go wrong for a particular customer in case, because uh, customers are going to be either 0 or 1. But when you do it over a large customer base of, like, for example, thousands and thousands of customers, you the estimate that you are going to get for the revenue that you're going to get in future would be very accurate and would adjust itself over customer to customer. So you do not have to look at a particular customer, but when you are looking at a population or a sample, these things will be correct, and you would get an understanding of the potential future revenue of the customer base that you have. Now your customer base has predicted like $10,000 revenue for next year. Now you are confident that the 10,000 is going to come to you, so you can spend 5,000 out of that in other activities, or even 10,000 of that in other future commitments, or like starting a new project in your company, or starting a research for a new project and spending that money, because that money you will be getting in future, and you're confident about that. Some of the important factors when it comes to like churn rate and retention rate is engagement, how engaged they are with the platform or the product, the time they are spending on that product, how much they are already into your product. Are they using it for like 3 months, 6 months, or are they like 2 days old, or like 1 day, or they have just started? All these things in end would impact the churn rate and the retention rate of every customer, and will impact the value of a customer that they will have in the future as well. So it will be a binary classification problem where you're predicting if they are going to stay for the next year or not. People generally prefer something which gives you a score, not just like the different 0 and 1 which we get in case of, for example, support vector machine. So you would rather go for a logistic regression which would give you the score from 0 to 100 rather than just giving you direct 0 and 1, because when you get a score, you can, over a population, you can predict the continuous value that a customer might have, rather than just predicting like this is the month that they are going to end their subscription, and count everything before that as like $50 and after that as like $0. uh, so it's easy to predict for the next month because you already know all these features for the month previous to it. But when it comes, for example, predicting the 10th month and seeing what would be the retention for the 11th month, you would have to change some of these variables. For example, the engagement that they have, or the month, if it is impacting for online education platform, you might see a lot of drops in the summer months. Or if you are selling some like warm coolers or like desert coolers, you might see this drop in the uh, winter months. So you have to keep your business in mind and adjust some of these variables with time. So when you're predicting for the future, you would get accurate representation of what the future will look like and predict the customer lifetime accordingly. So now following up to LTV is like find when the customers are likely to churn, looking at the features and the model that you have built, offer them discounts at that moment. I'm predicting like uh, after 3 months, I see a large drop from my platform. So at 3 month mark, I would give additional discount of like 20% or 10% to customers. So I pass that heavy churn period of 3 months, and then if the customer stays a little longer with me, I can hold that customer and have a larger future potential revenue with them. Generally, engagement is a strong indication. If the customer has stopped engaging, the engagement is decreasing of a customer with a platform, so we can continuously monitor the engagement. if the engagement is going down or the momentum is going down, we can send them emails or messages to bring that back up, so we can reduce the churn, and we can predict the churn to see, like, if the churn is going to be higher, what features can be shifted to lower that churn as well and keep that customer for a longer period of time. Then doing migration, for example, doing analysis like this, like 5% of the engagement increase in engagement will bring additional extra like $5,000 or like $500,000 of revenue to my platform. So these analysis will give you like spend in marketing like $10,000 or like $20,000, which would increase the engagement for 5% and will bring a 500,000 revenue. So is it worth to spend that 10,000? Definitely, I would spend that anyways. But all this can be only done once you have done this lifetime valuation analysis. You know the features that are impacting your engagement and how much improvement in the engagement is going to lead that change in the revenue in the end. uh, Other thing is like with online platform, a lot of them, like for Geo for example, offered this free internet for 1 year for everyone that they join. Once they finish that free, they might have seen a lot of churn, or like customers dropping out of their service just after that free period. So defining that free period from your past experiences and this engagement model to see like what should be the ideal length of that free period. Is it like it should be 1 month, 2 month, and how much free you should be? Is it like 20%, 50%, or completely free? So these kind of analysis will only be done once you have these models trained and you can have these features for the customers. Any questions so far? Any questions on LTV? Yeah, go ahead, Suresh.
Yeah, yeah. Hi, sir. My question is that on Firebase also we calculate the analysis, so it belongs to the same which we are talking about it.
Sorry, did you say Firebase?
Yeah, Firebase we get the analytics and all the things like regression values and all the things. It's the same like that we are calculating and all the things related to the AI models.
Sorry, I'm not that familiar with the Firebase, but I can definitely look after a chat and then we can like talk about that as well. Yeah.
Okay.
Okay, so coming to the last topic of the presentation is like digital marketing and attribution. So this is the newest and the hottest topic right now in digital marketing. Everyone almost is going crazy. There are very few experts in the market for this right now, but everybody wants it just right now and right then. But so what is attribution modeling? So basically, it is like majorly focused on digital marketing, how companies will know where the customers are coming from to their platform, where they want to spend. Is it take the Facebook ads? Is it the Google ads search, or is there ads on the newspapers, or is the ad on the television that is bringing the customer in? So everybody wants to know which is the marketing platform which brings in the most amount of customers, or like the most amount of revenue for the marketing effort, or like what we call as like return on investment. Uh, for a marketing channel. So, what is attribution modeling? Here is like understanding how your marketing channel is bringing customers to the product, rewarding the right channels. What we mean by rewarding is like, for example, Facebook is bringing you the most customers, so you start spending most of your marketing budget on Facebook ads and bringing the other budgets from like newspapers or TV advertisements down. Spend in marketing with confidence. So if you know like the Facebook is bringing most customers, spend freely on Facebook. Do not think about the about like how much money it is bringing, because you will know it once you have done the attribution modeling. A study in like 2017 showed that 92% of the customers visiting a retailer website for the first time aren't there to buy. They will just look around then they will do other things, and they will see multiple ads, then their belief will go stronger and stronger, and then eventually they go for buy. So we'll look at the complexities involved in attribution modeling. So first, I want you to introduce the marketing channels that are involved majorly. So there are paid channels, and then there are free channels. There are also online channels and offline channels. Offline channels can be like print, radio, TV ads. Online channels can be like your search engines, your social media platforms, your emails that you may right, or the banner ads you see on the platform, on the sites when you read some blogs, or even some associative like IMDb suggesting an Amazon link to go there and watch a movie. So that is also a kind of marketing, which is like associate marketing. So I will first go through some of the free channels, and for this attribution modeling, majorly these days companies are sticking to online platforms because those are more efficient and have a better return on investment. So some of the organic ways to know about a product is you just go on a Google, search for a Nike shoe, you like that shoe, go to the Nike website and buy it. So that is like organic search. You know about that product, or you went yourself and initiated that journey of a customer. There can be free social platforms. You follow a Nike page on Instagram, you just go look at the like they added a new product, they put a post or a story, you just get the product known from there, go to the website and buy it. Then there can be emails. Emails cost very less compared to other platforms, so sometimes they are kept as free channels, sometimes they can be kept as paid channels, but generally the cost of emails is very less, so people consider it as a free channel. When it comes to paid marketing channels, so as I talked about, there can be paid search. So you can be searching about Marriott, then you will get this advertisement on Google. So the first links that are advertisement links, these are all paid search links. So this is considered as paid search, and Google plays a, a particular price for each of the keywords, and companies have to pay keyword wise to put the ads and banners on these search platforms. So this is a kind of marketing which is very popular. Then there is affiliate marketing, which I just talked about earlier, like for example IMDb collaborating with Prime Video to get to write the reviews, and in place Amazon is getting a page. For example, you are reading the Star Wars review, you think you should watch it, just click on that link, go to Prime Video, pay for the movie. So Amazon is getting customers from IMDb. So it's kind of a affiliate marketing. Then there is display marketing. This is like kind of a display ad where you get it on the side of blogs. Then there can be paid social marketing as well, like you get these sponsored ads on Facebook, Instagram, Twitter, and this is like kind of paid social marketing. So this is for example, a customer journey. I just went to YouTube. I looked at uh, I looked at a video for a hotel or a blog for a resort. Then I got this advertisement on my Facebook about Marriott hotels. I ignored that advertisement or just looked at it. Then I went to this blog for example towards data science. Got another ad for Courtyard by Marriott about this resort. Then I googled about Marriott and got this link and went to their website. And then finally I booked a hotel room. Now the biggest question is, which of this platform led to this conversion or a booking that happened on this journey? Anyone wants to answer this question?
Sir, it's a paid conversion if we talk about.
Yeah, like there were various channels that involved. First was like YouTube, then there was Facebook, there was a display ad, there was a paid search, and then finally a conversion happened. Conversion means like the person booked the room. So what do you think, like which is the channel which was responsible for that conversion?
The main, I think, the paid conversation was as a Facebook. He was interested to pay via. Also, he check out on Google and he clicked on ads. So the main channel it's showing that paid conversation is conducting.
Okay, yeah, so like it can be the YouTube ad. it can be the Facebook, like the YouTube ad might have introduced him to the product. It can be the Facebook advertisement, or it can be the last like direct that he just went. So it's very tough to particularly give all this credits. You cannot just say that all the conversion went to should be given attributed to YouTube, or all of that contribution should be attributed to display. All of these channels played a big part in the final conversion. So there were various types of attribution models. These were all heuristic based. So first is like last touch. All the credit went to the direct search, which is like their own parent website. Or then there is first touch, which is like all the credit went to the first search, which is like the YouTube video that he saw. Then there is linear model. Just divide the credit or the conversion to all of them equally. Then there is position based, which is like first and last will get the maximum credit, and rest of them will get a smaller credit. Then there was time decay model, which like as the latest of the advertisement you saw, give more credit to it and keep decreasing it till you get the start of the customer journey. But there was this problem with all of these approaches. All of these approaches were very simplified, so you may get a lot of overconfidence in some of these channels and ignore the confidence of contribution of other channels. What I've seen generally is like display ads or the YouTube ads come very early in a journey of a customer. And for example, something which is like paid search or affiliate marketing comes very late in the customer journey. So, for example, if you're going for a first touch or last touch, you might not get the real picture of what is bringing your customer or what is leading to conversion. So this oversight can be very detrimental, and you can change your marketing efforts. But for example, you are focusing your marketing efforts on the last stages or like conversion stages, you will not be bringing those new customers in. If you're focusing on the bringing new customers in, you're not focusing on the channels that are leading to their conversion or finally them buying the product. So recently people have started using Markov chains for doing this. What Markov chain does is it describe a sequence of possible events in which probability of each of these events depends on the previous stage that were there. For example, if he was on this Facebook ad, it will give you the probability either going to a YouTube ad or all the different marketing channels in the next part of their journey or going to the conversion. So Markov chains in the context of channel attribution gives us this framework to model user journeys, how each channel factors into user traveling from one channel to other and eventually to the purchase or not buying that product. So it creates this whole map of probabilities, the user traveling from each channel to the other and finally getting conversion. So uh, this is kind of a transition matrix or a heat map that you get out of the Markov chain model that you are creating, and this is like basically a sequence of events that can be happening or have already happened for the customers that you have had in the past. So how will you calculate the uh, attribution in that? I think I missed a slide. So what you would do is you remove each of these nodes from the Markov chain one by one. For example, you would remove the Facebook node from the Markov chain, and then we'll see how once you remove that node, how many customers journeys can be completed in this Markov chain. Once you remove that node and see that decrease in the number of conversion that happened, you can attribute that number of conversions to that particular channel, and you can get the contribution of that channel in your marketing effort. So through this you can get marketing like conversions for each of these channels and can define their contribution and also the return of investment for each of this channel. So this is new, and people have started using like Markov chains for multi-touch attributions and to analyze their customer journeys, which are getting longer and longer as more platforms and options are getting available to them. What is next in MTA is like identifying a customer is very tough online because there are a lot of privacy issues. They have to depend on either cookie IDs to identify them, and cookie IDs can change from like platform to platform. Like if I'm using a Google browser right now, I will have a different cookie ID. As soon as I switch to Mozilla, my cookie ID will change. Similarly, if I change my device, my cookie ID will change. So companies are trying to create a centralized ID system where they can create these IDs and match them to the cookie IDs on different devices, or using something like IP addresses or the location of their devices to map customers to each other. Other algorithms people are using for multi-touch attribution is like Shapley method. So it is derived from game theory, and couple of people have started using it. One of the problem with the Shapley method is it's like when the number of channels increase or the combination of them increase, it is very tough to like compute it. People are also using higher order Markov chains like second order, third order, where the next event does not just depend on the previous event, but also all the like two or three previous events that happened before that. And then there are graph based neural networks which are very like at the very early stages, but I think they have the potential to deal with this problem as well. So any questions on MTA or how it is used uh, in the industry right now, or any other questions from the presentation so far? I would love to connect with you. So this is like my LinkedIn link as well. So please free to connect me. I would love to chat with you. If you have any other topics that you are working on or researching on, I would love to read more about you. And if you want to discuss any of these like methods or initially the bot and how I implemented it, or look at my code and like either my project that I did, feel free to reach out. I would be happy to connect and chat more about these topics and learn from you as well.
Yeah, is my voice audible?
Hello.
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 Yeah, I can hear you, Sailesh.
Yeah, sir. My question was that what are the tools which you have used to calculate the MTA model? Also, you have shown on the slide the first come in, last come in, and all the time delay for the how it's been calculated. Is there any tools which have you used to find the that models?
Yeah, I would say what I did use previously was like I used majorly Python to do all this. I depended on there is a Python library for Markov chain. I can't remember the exact name, but I can definitely uh, send you that later. But there are libraries in Python and R that are available. Plus, there are some paid tools that are available as well to do Markov chain. There are sample data sets on Kaggle available to do this as well. And there is a blog on Medium and towards data science on how people use Markov chain and in MTA as well. So those would be good places to start about MTA as well.
Okay, okay, sir. Mainly, if we talk about Google Analytics, so we used to calculate and trigger the person's uh, informations, but we do not get any information related to that field. We can only trigger the fields where it was gone and the user information. As we talk about acknowledgement only. So, is there a tool or anything that you can think we can get the user detail also using it?
Yeah, user detail is tough for MTA. Mostly, you will get a user known through its cookie ID, or sometimes, like for example, Adobe Analytics tools gives an EC ID. So it is trying to create a user map which would create which would map multiple cookie IDs to a particular user. And from that user using it browser information, it can give you the location of the user as well, and sometimes the browser that they are using as well. But I would say, like, as the privacy concerns right now in the industry are and will grow, it will be tough to identify that person and get more like value out of the customer information. But you can definitely get this information of what each platform is bringing you and if they're getting converted or not.
So if we talk about, we would be getting only their interest, and we would be sharing their according to their interest.
Yes. So basically, here we are not trying to identify the customer. We are more focused on identifying the right channel to get these customers to our platform.
Okay, okay. Thank you, sir.
Is MDA
Hello,
part
sir.
of AI or machine learning? I would say AI, machine learning, data science is a very loosely term. They are very tapping with each other. Uh, it depends on what model you are using. So if you are using something which is like graph neural networks on it, it would be like AI. If you're using Markov chain, it is majorly a data science or a computer science problem. If you're using something like as linear regression on top of it, it's data science problem. So it's an analytics problem that people are trying to solve. You can call it whatever you want to. When it comes to research opportunities and particularly the MTA area, I will as I said, like one is like identifying the relations, like how to match these cookies with the IP addresses and coming with a definitive matching criterias and effective matching of these customers, to exploring like what how Adobe is using its ECID and what criteria it is using to match different cookie IDs to one person. That is definitely one area. Other is like exploring Markov chains. So Markov chain has these issues of decrease in performance when the number of channels increase exponentially. For example, right now we have 8 channels, but if you want to go deeper into these 8 channels as well and get to their subdomains, that is a challenge that Markov chain right now is not dealing very efficiently with. So is there a way to optimize that? Is there a way to like calculate these attributions in a faster way? And exploring other methods such as I mentioned, like there is Shapley method of game theory which people are using. So exploring that method and seeing like what are the advantages and disadvantages, because this is a really popular topic right now. So any research or like the like you break any like the barriers here would definitely go a long term. Okay, I think we had the questions. Abhishek sir, do you have anything else for
Uh,
us, or we can end it like little earlier and give everyone like 20 minutes back?
yes, definitely. I guess there was one question which I guess we left earlier. Just a second. Forgot earlier. So there was this one question that I think we forgot earlier. So the question was, does the BERT model can be used on image to text description?
No, this is very specific to text right now. There are other models which are being built, which give you like subtitles for images or even like what is happening, like a brief summary of what is happening in the image. But Bird does not do that.
Okay. So if there are any more questions, we'll just wait for 2 more minutes and then we'll wrap up the session. It's
Okay, sure.
quite late for Shloak at US right now, so I guess it's better that we let him sleep now.
Yeah, it's like 12:30 in the night right now, so that's fine.
I guess there are no more questions. Let me check on YouTube as well.
Yeah, sure.
Also on YouTube as well, there are no questions. So, with that, Shloak, I can say that it was like a really nice session. It was quite interactive as well. I can see that a lot of participants were actually eager to get their queries solved and get particular responses. So overall, it was a very informative session. That is like the first thing that I would say about this. So you covered a lot of things from market analytics and how like AI or related models can be used to solve those problems. And also, the best thing about this particular session was that you included a lot of use cases from actual businesses, actual companies, how they are trying to do it, how they are trying to solve these issues, and why they matter. So that is like a very good insight into any such problem because that is where most researchers like suffer to a certain extent because if you cannot understand the why behind a problem, you cannot solve it. That is like was a very good part of this today's session. So with that, if there are no more questions from the whole of the organizing team, I would like to thank you for joining us today. It was really nice to have you here. And just as we have been doing it since yesterday, at the end of every session, we like to take a picture, a kind of a screenshot rather than a picture. It is like a screenshot of all people who are joining. So I request all the participants to like, turn their camera on for a minute and then we'll take that screenshot. So that will like act as a memory for all of us.
I think camera is disabled.
Okay, I'll have to enable that. Just a second. It is enabled now. Please try to enable your cameras now. It should be possible. Okay, so is everyone ready? I'll count down.